Hello students, how are you? Welcome everyone to my power station class. Today we will discuss on generating stations. We know modern world is totally dependent on electricity. The economic development, living standard, education of a country is totally dependent on the electricity. The greater amount of power a country can use, the greater the country is developed. So we can see that the scale of economic development mostly dependent on electricity. The ever increasing use of electricity for domestic, commercial and industrial purposes necessitates to produce bulk electric power economically. This huge power is achieved with the help of suitable power plants or electric power generating stations. Importance of designing a power plant. The selection and placing of the necessary power generating equipment should be such that a maximum return will result from minimum cost. The operation should be such that as to provide cheap, reliable and continuous service. We are engineers. The main purpose of an engineer to design a system in order to achieve a maximum return in minimum cost. So when we design a power plant or power generating stations, we should be kept in mind that our cost will be minimum, but in return we will get a maximum amount of power. Generating stations. Bulk electric power is produced by a specific plant known as generating stations or power plant. Today, a small power generating unit such as diesel generators are used in many houses, offices or apartments. But we cannot treat this type of unit as power plant. To be a power plant, it is necessary to produce huge power. Classification of power generating stations. Depending upon the form of energy converted into electrical energy, the generating stations are classified as under steam power station, hydroelectric power station, diesel power station and nuclear power station. Steam power station. A generating station which converts heat energy of coal combustion into electrical energy is known as steam power station. In a steam power station, steam is produced in the boiler by utilizing the heat of coal combustion. The steam is then used to rotate a turbine. The steam turbine then drives the alternator which converts mechanical energy of the turbine into electrical energy. This type of power station is suitable where coal and water are available in abundance and a large amount of electrical power is to be generated. Advantages of steam power station. It has less initial cost. It requires less space. It can be installed at any place. Fuel use is cheap. The cost of generation is lesser than other types such as diesel power station. Disadvantages of steam power station. It pollutes the atmosphere, as in a steam power station huge amount of fume is produced and which is harmful to the atmosphere. Running cost is greater than hydroelectric power station. Okay students, now we'll discuss on the schematic arrangement of a steam power station. It is shown in the figure. Although steam power station simply involves the conversion of heat of coal combustion into electrical energy, but it has many arrangements for proper working and efficiency purposes. The whole arrangement of a steam power station can be divided into coal and ash handling arrangement, steam generating plant, steam turbine, alternator, feed water, and cooling arrangement. At first we come to the coal and ash handling arrangement. In a steam power station, coal is transported by road or rail, and then it is stored in the coal storage. Storage of coal is primarily a matter of protection against coal strikes, failure of transportation system, and general coal shortages. From the coal storage plant, coal is delivered to the coal handling plant where it is pulverized, that is, it is crushed into small pieces in order to increase the surface exposure. The pulverized coal is then fed to the boiler by belt conveyors. The coal is burned in the boiler and then ash produced after complete combustion of coal, which is removed to the ash handling plant, and then it is delivered to the ash storages for disposal purposes. Now, steam generating plant. The steam generating plant consists of a boiler, superheater, economizer, and air preheater. In a boiler, heat of the coal is utilized to convert water into steam at high temperature and pressure. The flue gases from the boiler make their journey through superheater, economizer, air preheater, and finally it is exhausted to the atmosphere through the chimney. Superheater. The steam produced in the boiler is wet and is passed through superheater where it is dried and superheated. Superheating provides two principal benefits. At first, superheating increased the overall efficiency. Secondly, too much condensation in the last stages of the turbine is avoided. Economizer. An economizer is essentially a feed water heater and derives heat from the flue gases for this purpose. The feed water is fed to the economizer before supplying to the boiler. The economizer extracts a part of heat of flue gases to increase the feed water temperature. Air preheater. An air preheater increases the temperature of air supplied for coal burning by delivering heat from the flue gases. Air is drawn from the atmosphere by forced draft fan and is passed through air preheater before supplying to the boiler furnace. The air preheater extracts heat from flue gases and increases the temperature of air used for coal combustion. Steam turbine. The dry and superheated steam from the superheater is fed to the steam turbine through the main valve. The heat energy of steam when passing over the blades of turbine is converted into mechanical energy. After giving the heat energy to the turbine, the steam is exhausted to the condenser, which condenses the exhausted steam by means of cold water circulation. Alternator. The steam turbine is coupled to an alternator. The alternator converts mechanical energy of turbine into electrical energy. The electrical output from the alternator is then delivered to the busbar through transformers, isolators, and circuit breakers. Cooling arrangement. In order to improve the efficiency of the plant, the steam exhausted from the turbine is condensed by means of a condenser. Water is drawn from natural source of supply such as river, canal or lake and is circulated through the condenser. The circulating water takes up the heat of the exhausted steam and itself becomes hot. This hot water coming out of the condenser is discharged at a suitable location down the river. In case of availability of water from the source of supply is not assured throughout the year, cooling towers are used. That is, when waters are not available, in that case we use cooling towers. During the scarcity of water in the river, hot water from the condenser is passed on the cooling towers where it is cooled. The cold water from the cooling tower is used in the condenser. Choice of site for steam power stations. In order to achieve overall economy, the following points should be considered while selecting a site for steam power stations. Supply of fuel. The steam power station should be located near the coal mines, so the transportation cost of fuel is minimal. However, if such a plant is to be installed at a place where coal is not available, then care should be taken so that adequate facilities exist for the transportation of coal. Availability of water. As in a steam power plant, huge amount of water is required for the condenser. Therefore, such a plant should be located at the bank of a river or near a canal to ensure the continuous supply of water. Transportation facilities. As in modern steam power plant, it is necessary to transport heavy machineries or materials. Therefore, adequate facilities should be provided for transportation purposes. Nearness to load center. In order to reduce the transmission cost, the plant should be located near the center of the load. Distance from populated area. As huge amount of coal is burned in a steam power station, therefore a smoke fumes pollute the surrounding area, so that the plant should be located at a considerable distance from the populated areas. Cost and type of land. The steam power plant should be located at a place where land is cheap and further extension is necessary if possible. Efficiency of a steam power station. There are two types of efficiency: thermal efficiency and overall efficiency. In a steam power station, generally the overall efficiency is lower than the thermal efficiency because a huge amount of heat is lost in the condenser, and also heat losses occur in various stages of the plant. Thermal efficiency. The ratio of the heat equivalent of mechanical energy transmitted to the turbine shaft to the heat of combustion of coal is known as thermal efficiency. Overall efficiency. The ratio of the heat equivalent of electrical output to the heat of combustion of coal is known as overall efficiency of a steam power station. Generally, in a steam power station, thermal efficiency is about 30%, overall efficiency 29%, and overall efficiency is less than the thermal efficiency.